Hello everyone and welcome back to my channel Lessons at Fingertips. Here we discuss on some important topics in really simple words so that it's easier for you all to understand and keep things in mind. Today our topic of discussion is going to be properties of indifference curve. Well, in my earlier video we have already discussed what are the axioms of indifference curve, right? Now we are going to read about the four important properties of indifference curve. The first and the very important one is IC curve slopes downwards. Okay, that is, it is negatively sloped. How do we usually see the IC curve? It is sloped like this, isn't it? This is a commodity Y, this is a commodity X, and this is the IC curve. Now, why does it slopes negative? The one and most important reason is that whenever you are purchasing a commodity X, now, if you are purchasing X 1 unit of commodity, you are purchasing what? Y 1 of commodity, isn't it? Now, to increase the consumption of Y to Y2, you need to sacrifice some amount of X, and that is the reason why indifference curve is negatively sloped. You see, we always have limited resources. Now, within that resource, you need to get the maximum utility. Okay, we all know that along an indifference curve, the level of satisfaction or the utility remains the same. Got it? Now, when it is remaining the same, you need to choose the bundle which will be beneficial for you. If you know that I need some more commodity X, so I will consume more of X and less of Y. Similarly goes for the Y commodity also. So, but you must be knowing that my resources are limited. Now, to satisfy within that limited resources, if I am consuming some more unit of X, definitely I will have to reduce the consumption of Y. And that is the reason why IC curve slopes downwards or negatively slope. The second important thing is two IC will never intersect each other. We have already read this in the axioms of IC curve. If you have two ICs like this, it is never going to intersect each other. It cannot intersect each other. Why is that so? I will tell you. See, if this is an IC curve, right? Now this is a higher IC following here. Now, if this is a higher IC, now we have a point here, this is called A. We have a point here, this is called B, and we have a point here, this is called C. Two ICs are intersecting each other, right? Now, what does this imply? As per the axiom of transitivity, we know that here A and C, A is indifferent to C. Why? A is indifferent to C because both are lying on the same IC curve, right? Also, C is indifferent to B or B is indifferent to C. Why? Because that two are also lying on the same IC curve. Now, we know that this one is on a higher IC, A is on a higher IC, so definitely A will be preferred to B. A has to be preferred to B because higher the IC curve, higher is the level of satisfaction. So, A is a point on the higher IC curve which is suppose IC2 and this is IC1, right? So, now you see if A is indifferent to B and B is indifferent to C, will imply as per the axiom of transitivity that A will be indifferent to B, isn't it? But is that true? No, it is not true. So what is happening is that whenever two ICs are intersecting each other, the axiom of transitivity is violated. Got it? So now that is why we say what IC curve will never intersect each other. They are parallel lines. The third one is higher the IC curve, higher is the level of satisfaction. Yes, you see, if this is an IC curve, this one is IC naught, right? It is giving this much of satisfaction, okay? X naught unit and Y naught unit. Now, if I am having a higher IC curve like here, right? So, with the same Y naught, I can consume more of X commodity, isn't it? तो मेरे को Y को sacrifice नहीं करना पड़ रहा है. But if in the same IC curve I wanted to consume more of X, I would have sacrificed some unit of Y, isn't it? I had to sacrifice some unit of Y. So now I don't actually need to sacrifice any unit of Y. Rather, IC curve, if I am going for higher IC curve, you see more y, more x, more of y, more of x, isn't it? So higher the IC curve, higher is the level of satisfaction. Now what is the problem here? We do not actually have that much of budget that we will be affording higher IC curve, and that's why we have something like this called as the budget constraint, or which is the optimal point, the IC curve which is tangent to the budget constraint, that is the optimal point. IC curve below budget constraint, not optimal point. IC curve above budget constraint cannot be afforded, not optimal point. So IC curve which is tangent to the budget constraint is the optimal point. The last and very important one is IC curve. ICs are convex to the origin. What does this imply? IC is convex to the origin means the marginal rate of substitution. It implies the marginal rate of substitution which is diminishing. What is marginal rate of substitution? We have already discussed that for every unit, for increase in every unit of consumption of one commodity, you need to sacrifice another commodity. Now the rate of sacrifice, that is marginal rate of substitution. What is that? See, if you are consuming, suppose a commodity M and a commodity N, okay? Now to increase the commodity M, suppose by del M, how much you are willing to sacrifice the N commodity, that is del N. What is the change in del N? Okay, so MRS of what? MRS of Mn. What is Mn? MRS of Mn implies how much you are willing to sacrifice N commodity for increasing the consumption of M commodity. And what it will be? It will be negative sign of del N by del M. Why is it negative sign? Because you are substituting, you are reducing the consumption of N for increasing the consumption of M. Remember, what is MRS of Mn? Means to consume more of M, how much you are willing to sacrifice N. Got it? And then we write it del N by del M. Similarly, we can find what MRS of Nm means how much you are willing to sacrifice M for increasing the consumption of N. And how we are going to write that? Del M by del N, that is negative sign must be there. But while writing the answer, we consider it within the mod value so that you can just, omit the negative sign. But while you are writing the formula, do write the negative sign. Another thing is, what is actually Mn? That is nothing but marginal utility of M by marginal utility of N, MRS of Mn. Okay, so now let's move on to a little bit of explanation of diminishing marginal rate of substitution. Now there is another concept why we are saying convex. We are sacrificing one commodity for the consumption of another commodity, but that is same as the property of downward sloping indifference curve, isn't it? But why are we saying it is convex to the origin? That means what? Towards the axis it is flattened like this, and then here also again axis it is flattened. Why does this happen? You see, whenever you are, suppose this is the y, this is the x, right? This is the y, this is the x. Now when you are consuming some more of x like this, if you are consuming some more of x, now the rate of substitution will diminish. What does that imply? Suppose earlier you were consuming 10 units of x, okay, and 5 units of y. This was your budget constant, or this is what you can consume. This is the the combination or the bundle that you were consuming. Now you are willing to consume suppose more of y, okay. So you will be sacrificing x, you will have to sacrifice x. So now to consume 6 units of y, you are consuming only 8 units of x, okay. Now if I am willing to consume more units of y, suppose 5 units of y, I am reducing only, I am consuming 7 units of x. That means what? I am reducing my level of substitution, the level by which I was decreasing the consumption of x. Why is it happening so? When you are reaching towards the axis, that implies that now the other resource is scarce. Now y is scarce. You are already consuming so much of x. So y abhi scarce resource ban gaya hai. So when it is now limited available, you are not willing to give it up much. क्योंकि अभी तो मेरे को x इतना मिल ही रहा है. I am already getting this much of x. But y तो मेरे पास अभी और है नहीं ना. So to increase the x, I cannot afford to lose y now. I have reached to that position. So this is the significance of the convex IC curve. Means अभी यहाँ पे जब I am here, you see, the level of sacrifice is very less. The level of sacrifice is very less, isn't it? इतना सारा y बढ़ाने के लिए I am just sacrificing this much of x. Okay? Why? Because I already have this much of y. I already have this much of y. तो अभी x तो मेरे पास है नहीं ना. x I am having very less. Only this much. Only this much x I am having. So अभी हम कितना ही x sacrifice कर सकते? नहीं कर सकते. So this is the significance of convex. This property of IC is convex to the origin, and this is the reason why we say diminishing marginal rate of substitution. Means the marginal rate of substitution होगा, the rate by which we are ready to sacrifice commodity n for commodity m, वो reduce करता जाएगा, वो diminish करता जाएगा whenever you are reaching towards the axis. That is why we call it is convex to the origin. Got it? Now another thing is what MRS of Mn. MRS of Mn is nothing but marginal utility of m by marginal utility of n, which is again equals to del n by del m. That is change, how much you are changing the consumption of n for increasing the consumption of m, right? So change we are measuring here. So simply I can say here is that MRS of Mn is nothing but m marginal utility of m by marginal utility of n, isn't it? Now we will do a nice problem to show the equilibrium of this formula. Got it? Now to prove that MRS of Mn is equals to marginal utility of m by marginal utility of n. To prove this, let us take a utility function which is u as a function of m comma n. Let me take this utility function. Along the IC curve, the utility is going to remain the same. That is u equals to u bar. We know along an IC curve, the utility remains the same. Now, what is the marginal utility of m? What is mu marginal utility of n? That is nothing but del u by del m, isn't it? This is the marginal utility of m. And what is the marginal utility of n? That is nothing but del u by del n. This is how we find out the marginal utility, right? Now, what if I differentiate this function totally? Then what do we get? We get is du. I need to calculate, right? So for du, what do I get? Del u by del m into du dm plus del u by del n into dm. This is what we get, isn't it? Now, we already know that along an IC curve, the marginal utility is constant. So, we must be knowing that du is actually equals to 0. तो इसको हम लोग 0 सेट कर देते हैं. What do we get? We get is del u by del m plus dm. Sorry, into dm plus del u by del n into dn must be equals to 0. इसको 0 सेट कर दिया हमने. Why we set it 0? Because along an IC curve, the level of utility is going to be the same. तो utility यहाँ पे constant है ना? So now after this, what should be our approach? We can write it like this: del u by del m, del u by del n must be equals to what? dn by dm, isn't it? This is what we get. Now what is del u by del m? It is marginal utility of m. By what is del u by del n? It is marginal utility of n, which is equals to del n by del m. What is this? it is nothing but MRS MN. So we have proved here that the marginal rate of substitution of Mn is nothing but the marginal utility of M by marginal utility of N. So this was about the diminishing marginal rate of substitution. So we have here studied about the properties of IC curve, the very important property of IC curve, that is convex to the origin. With regarding to that, we have studied diminishing marginal rate of substitution. So I hope you guys have liked this video. Please do hit a like, share with your friends and subscribe to my channel. Do write in the comment section below guys if you have really liked this video. Till then, bye bye.